we've already seen that metals bond to nonmetals through ionic bonding, and that nonmetals bond to other nonmetals through covalent bonding. This video is about the last type of bonding, metallic bonding. What happens when a metal bond with another metal? Let's look at how metallic bonding works. This is what the structure of a metal looks like. So what you've got here is, you've got layers of positive metal ions, and you've got what we call a sea of delocalized electrons. Delocalized just means that those electrons are free to move throughout the structure. Now, when I'm talking about delocalized electrons, what you might be thinking is which electrons get delocalized. So here is my electronic configuration for sodium 281 in its outer shell, and in terms of which electrons get delocalized, it is just those outer shell electrons. So for sodium only one electron gets delocalized, not all of them. In terms of what holds this whole structure together, it's really similar to ionic bonding. However, within the metal itself the atoms are held together by an electrostatic force called metallic bond. Metallic bond refers to the electrostatic force formed between the sea of delocalized electrons and metal ion. In real-life substances involve tons of atoms bonding together. If we look at a solid metal, it consists of a giant structure of atoms that are arranged in a regular pattern. Each atom is surrounded by the electrons in its outermost shell. Metallic bond is a strong force, which requires a significant amount of energy to overcome. Leading metals have high melting and boiling points and are solid at room temperature, except mercury. Because the localized electrons can move freely within the metals, they can carry thermal energy, so this makes metals good conductor of heat. In a piece of metal, the delocalized electrons move freely in all directions. However, when both ends of the metal piece are connected to a battery, the delocalized electrons move in one direction only. An electrical circuit is complete in Figure 1. When electricity passes through the metal rod, the light bulb glows. Therefore, metals conduct electricity. If you hit a metal with a hammer, it doesn't break, it just dents. Metals are able to deform in response to an applied force. The mobile sea of electrons shields the cations from each other, preventing violent repulsion, and allowing the metal to change shape. The most malleable metal is gold. A similar property to the malleability of metals is their ability to be pulled into long thin wires. We call this ductility. Alloy is a mixture of two metals, or a combination of a metal. Some examples of alloy are steel, which is made of iron and carbon. The combination of metal and non-metal are picked in different atom sizes. The different sizes of atoms help to disrupt the metal's regular structure, which prevents the layers of atoms from sliding over one another, making them much harder than pure metal. Brass, which is made of copper and zinc. Bronze, which is made of copper and tin.